So just going to do a quick video on interpreting derivatives. I'm going to mainly use the notes that we have here. So we'll skip over some of the bits because we've covered them in previous sections, like our turning points here, or things about second derivative test. We'll just kind of skip over them a little bit. But looking at some of the bits maybe that we can just fill in here. The first one is looking at if your derivative is positive or negative, and does that tell us anything? And what we'll see here is that if your derivative is positive, then that means that the original function is increasing. And similarly, if your derivative is negative, then the initial function is decreasing. Okay, and what does that mean in practice? Well, if we look at a function like a quadratic function like this one here, we'll say like this one here, and this is the sort of function that we kind of introduced our differentiation with. And we said if we picked different points, say like this point here, and draw our tangent to the curve and all of these things that we did from before, at this point, that tangent would have a negative slope. Okay, so it would have negative slope. So again, dy dx would be less than 0. If we think about then the curve itself, what is it doing at that point? That curve is decreasing. So the curve is decreasing at that point. So all the way along the left-hand side there that I've shaded in yellow, my curve is decreasing. And for any point there, the derivative will be less than 0. Okay, so this is actually something that we would have already covered, but it's just making it really explicit here. Similarly, if we go on the other side, so picking a point here, or even a point down here, just to make it even clearer, drawing my tangent would have a positive slope. Okay, a positive slope. And what do we know about the line at that point, about my curve at that point? My curve is increasing for all the values here. My curve is increasing at that point because we've passed our turning point and now we're increasing. And for any point there, my slope will be positive. And that's what we have over this side. This blue part correlates, I suppose, with the blue section on the graph. The yellow part goes with this section here. So if my derivative is less than 0, my function's decreasing. If my derivative is greater than 0, then my function is increasing. And we see the similarities there between the slopes of the tangents and that idea. That if we look at the tangent, we see the slope is positive, and that really only happens when my function is increasing at that point. And what we're going to see in the next little bit, so I'm going to skip over the turning points as I said there, and I'm going to look at this one here of graphing. And the graph of your derivative actually helps us with a lot of this information as well. So if we look at these two graphs here, so on the right hand side, on the left hand side I have a quadratic, and on the right hand side I have the derivative of that quadratic. I'm actually seeing there an issue with our notes, so we'd have to change that one. So just to rewrite our quadratic in here, it should be 2x squared plus 8x plus 6. But we have our quadratic and we have our line on the right hand side. And there's a point that I've put in here as a note, and it's if we start with a cubic function, then our derivative is going to be a quadratic function. And that should be fairly clear. If I start with a function that has x cubed, no matter what comes next, if I get my derivative, that x cubed will become 3x squared. And then I will have a quadratic function. I may have other terms, but the highest power of x tells us what type of function it is. So if I start with a cubic, my derivative will be a quadratic. Similarly, if I start with a quadratic, my derivative will be a linear function because it will just have a power of x to the power of 1. So we can see that as we move down, as we get those derivatives, we're going kind of cubic to quadratic to linear, and then we would just get a straight line that wouldn't be dependent on x at all. So looking at the example we have here, we have a quadratic on the left hand side, and as expected on the right hand side, our derivative is going to be a linear graph. And if we look at these things to see if we can spot any key points here, the first point we're going to look at is in the middle here, the -2. On my right hand side, -2 is there on the x-axis. If we remember, that's when your y is equal to 0, when f of x was equal to 0. Now the function I have here, and it's a little hard to see just on the screen, but the function I have here obviously is my derivative, it's f dash x. And this line, the y-axis, the x-axis, is where my f dash x is equal to 0. It's the roots of my function. So we should remember this from our function section. So it's the roots of my function, or for this case I suppose the root of my function. And the root of my function is when x is equal to minus 2. And we can see where does that come up with our quadratic function. And we see it here. And we should recognise that at this point we have a turning point. So interestingly, on the left hand side where we had a turning point, on the right hand side that's the root of my graph for my derivative. And that should kind of make sense to us because we think about, okay, where does a turning point happen? It happens when my derivative, my dy dx is equal to 0. And my dy dx is equal to 0, if I've drawn the graph, that's at that line, at that x-axis. So that's a good way to spot the graph of the derivative. We look at where it crosses the x-axis and it should correspond with the turning point of my function that I started with. The other things we can look at is where is my derivative positive and negative, as we were just saying there. Okay, so my derivative on the right hand side here, dy dx, is greater than 0 for all these points here. Okay, any point here that's above the x-axis, that's where dy dx is greater than 0. And it's less than 0 for these points down here. It's negative for all these points below the x-axis. And how does that relate to my function on the right hand side? Well, we can see that for any value of x below minus 2, so to this side of minus 2, my function is actually decreasing, it's coming down. And how does that relate to my derivative graph? Well, on my derivative graph, that was all the negative values. So we can see that if I mark this in with the red line here, just to link it up with the derivative graph, we can see that for all the negative values in my derivative, where my derivative is less than 0, that's where my function is decreasing. Similarly, for any values of x here, where my function is increasing, my derivative is going to be greater than 0. So that's just bringing back the point that we looked at there already. If my derivative is greater than 0, my function's increasing. If my derivative is less than 0, my function's decreasing. So these are some things that we might be able to work out for ourselves, but it's just kind of making them even clearer for us now so that we can see it even more clearly, I suppose. Looking at a question like this one here, so matching the following functions to their derivative, to their first derivative, we have a, b, and c. So we can see that one of the functions is a cubic function and the other two are a quadratic function. So from what we said earlier, a cubic function, when differentiated, will give me a quadratic function. Okay, whereas a line, a linear, or a quadratic function will give me a linear function when I differentiate it. Okay, so if I write that out in words, cubic goes to quadratic and quadratic goes to linear. So what does that mean for us looking at these questions? Well, what it means is that if I look at b here, it's a cubic. So when I differentiate it, I should get a quadratic graph, which means b is going to be my graph here for 1. The derivative of b is going to be 1. Okay, looking at the other two, we have to decide which is which. And there's a few ways that we can do that. Okay, without actually differentiating it at all, we could look more closely at the functions themselves, okay, and take a guess at what they might look like. So say picking a first of all, we see it's an x squared, so we're expecting it to be a linear. We're expecting dy dx. So even say dA dx. Okay, we'll keep it simple. For this one, it should be linear, and we're expecting that it will be a line that's increasing. And why am I expecting that? Well, if we look at the value of the function that I have, x squared plus 4x plus 3, that's a positive quadratic. Okay, in front of x squared we have a positive 1. Okay, we don't have a minus. And a positive quadratic is U-shaped. Looks like this here. Okay, if we follow what it means to be U-shaped, it means that it starts decreasing and then it finishes and starts increasing. Okay, in terms of our line, we are looking for a line then that starts negative but ends positive. And if we look at our two lines, this one over here starts in the negative below the x-axis but ends in the positive. So that's going to be my A here. Sorry, I'll use the green. So that's going to be A here. It's going to be 3. And lastly then we're looking at C, so obviously we know already that it's going to be 2. But applying the same idea that we did with the last one there, this here has a minus x squared, which means it's n-shaped. So that means that it starts by increasing. Okay, so it starts by increasing, and it then ends decreasing. So it's going to start in the positive but end in the negative. If we look at number 2, sure enough, starts above the x-axis in the positive, ends below the x-axis in the negative. Okay, so a lot of this maybe might seem a little too abstract for you, and it could be something that we'll come back to and that we'll just kind of work on when we get the other aspects down, when we really understand what our derivatives mean and things like that. But the simple idea of maybe knowing that a cubic becomes a quadratic, the derivative of a cubic is a quadratic, the derivative of a quadratic is a linear graph, and the idea of maybe if the graph is U-shaped, then we would expect our line to be similar, to be increasing. If the graph is n-shaped, if it was a quadratic, then we would expect the derivative to maybe start high and go low, so to be decreasing. Okay, so these ideas, negative slope, all of these things that we're kind of used to talking about, it's just pulling them together in terms of how do they relate to our graphs. So it might be a little bit of a step into kind of the more deeper understanding based on what we've done already.